All right, welcome back. So now we're going to talk about the number of complex zeros of a polynomial. So if we take the last two theorems, the fundamental theorem of algebra and the linear factorization theorem, then we can also deduce that from those two things that we have, we can say more, right? So the fundamental theorem of algebra says that if we're given a polynomial with complex coefficients with a degree of at least 1, then there exists at least one complex zero. Okay? And then the linear factorization theorem says, hey, if we have a polynomial of a degree 1, right, and where the leading coefficient is not 0, then we can factor the polynomial into a product of linear factors. Okay, where all of the c values, right, the x minus c, all of the c values in the factors are all complex numbers. Okay, so now what we can do is we can say, okay, well, based on that, then we can say that if f of x is a polynomial of a degree at least 1 with complex coefficients, then we know that f of x has exactly n complex zeros. Provided, right, because remember, in the linear factorization theorem, all of those c values are not necessarily unique. So we could say that there's going to be exactly n complex zeros, provided that we count each zero by its multiplicity. Okay, so there's repeated roots, repeated zeros. Okay, so that's it. So that's the number zero. So again, if we have a polynomial degree at least 1 with complex coefficients, then we can know that there are going to be exactly n complex zeros if we count those zeros based on their multiplicity. Okay? All right, that's it.